Okay, so for part 2 of the 6.1 here, this is just from the need to know kind of recap session or review session at the end of the section. So I'm just going to go over with you the polynomial functions and some of their common characteristics. So it says the graphs of polynomial functions of the same degree have common characteristics. Okay, so if we have a degree where the constant is 0, what you will notice then is you're going to have a straight line. So for example, if our equation was y is equal to, say, 6, okay, so if our degree is 0, that means our x would have had a power of 0, so that would just be a 1. So we wouldn't actually exist. So if y is equal to 6, then we go up at 1, 2, 3, 4, 5, 6 here, and we draw a line through there, and that would be our graph. If we had y is equal to -4, we go down 1, 2, 3, 4, and your graph would look like that. Okay, so the number of x-intercepts then for a degree of 0 would be 0 except for the equation y is equal to 0. Because in that case, that would be this line right here. And that would mean that we would have an infinite number of x-intercepts. Number of y-intercepts, there's 1 right where it crosses the graph. The end behavior, so if we remember, this is quadrant 1, 2, quadrant 3, and quadrant 4. The line will extend from either quadrant 2 to quadrant 1, like my top picture there, or it will extend from quadrant 3 to quadrant 4. Our domain for this one can be any x value. So its domain is the set of values for x such that x is an element of real numbers. So we can use whole numbers, we can use fractions, decimals, negatives, anything. The range then, it's a set of values for y, and y then is just equal to whatever the constant was. So in our first graph, it would be y is equal to 6. Second graph would be y is equal to -4, or the y is equal to 0. Okay, so it just depends on what that is. Number of turning points, well, there aren't any. It just simply goes in a straight line. So if we had a degree of 1, we then have a linear equation. So depending on what the equation of that graph is, I'm just going to grab my textbook here. I thought maybe it gave me the equation and I forgot to write it down, but so whatever you draw, so your one equation, let's say it crossed here and it had a our slope was going like this. So you can just draw basically whatever line you want. So this would be a positive slope, or we could have a graph. Let's put it going through the origin, so it would look like this. So it can go, if it's linear and it has a degree of 1, then it can go in any direction really, but it's not going to be straight up and down, and it's not going to be completely horizontal. So the number of x-intercepts, it'll always have one x-intercept. The number of y-intercepts is also 1. The end behavior, the line is either going to extend from either quadrant 3 and eventually would hit quadrant 1, or it's going to go from quadrant 2 and eventually extend into quadrant 4. Domain for this is all real numbers, as is the range. Number of turning points, again, it's 0. It's a straight line going in one or the other directions. I had to do a little cutting and pasting because this went sideways on my paper, so you'll just have to bear with my paste here. So for a degree of 2, that is a quadratic equation. And there's a few different ways that a quadratic equation could go. If you remember from back in Pre-Calc 20 and Foundations 20, you can either have 0, 1, or 2 x-intercepts. So for 0 x-intercepts, you could have a graph that looked like this, or it could be a graph that looked like that. For 2 x-intercepts, your graph could be going like this, or it could be upside down in any quadrant, but you would have your 2 x-intercepts, or you could have a graph with 1 x-intercept. So if we had that, it could look, I'm going to put this one through the origin just so it's not touching the other one, so it would look like that. So your lines then, or number of y, intercepts, there will be only 1. So regardless of which one of these graphs even you looked at, eventually my first graph here would cut that y-intercept, but only the right arm would do that. And same with this graph, only the left arm would cut it. This, in my origin one, it is cutting the y-axis already. And then my upside down one would eventually also cut the y-intercept at one spot. So the end behavior, the line extends from, so it's either going to be going eventually from quadrant 1 into quadrant 2, so that's the end behavior. It'll start in quadrant 2 and go into quadrant 1. So quadrant 2 to 1, or it's going to start in quadrant 3 and then end in quadrant 4. What's our domain and our range? Our domain is a set of values for x such that x is an element of real numbers. Our range is going to depend on whether or not our graph is going up or down, so whether or not it's maximum or minimum. So our range is going to be set of values for y such that y is less than or equal to something if you have a maximum. or your range is going to be the set of values for y such that y is greater than or equal to whatever your minimum was. And for both of these, y is an element of real numbers. Number of turning points, you're going to have 1. Okay, so if you have a cubic function, that means your degree is 3. And you have a few different options for this one. So you could have a graph that behaves like, oh, let's see. I'm trying to make that one just touch. Okay. So it could go like this. So in this case, you have 2 x-intercepts. Oops. Or it could go like this. So in this case, we have 3 x-intercepts. Or it could, if it had a negative a value, it could just go like this and have 1 x-intercept. So you have 1, 2, or 3 x-intercepts, depending on the graph, the equation of the graph. It's only going to cross that y-axis in one place. So my first graph, eventually this line here is going to cut the y. This, in the second one or the middle one, it is cutting it. And in the third one, my bottom half here is going to eventually cut the y-axis. So the end behaviors. The graph is either going to start in quadrant 2 and eventually end in quadrant 4, like my first 2 ones, or it's going to start in quadrant 1, or well, I guess I would start from left to right, so it would be starting in quadrant 3 and eventually going to quadrant 1. So even though this graph here looks like it's in quadrant 4, this one here would eventually, as it continued going down, would be in quadrant 3. So that's why we say it goes from quadrant 3 to quadrant 1. Our domain, so for these graphs, again, you can use any x value that you want. As for the y, the range is also any real number. Number of turning points. So you're either going to have 0 turning points, like we do in the third graph here, or 2, where it changed, went down, came up, back up, and goes down. So 0 or 2. So this is just meant to be a just kind of a little guide or a cheat sheet for you as you're working on the assignments. Of course, you can't take it into your final, but it is something that you can use to help you as you're preparing for your final.